This is a process developed by the Monsanto company in 1966 as an industrial method to manufacture acetic acid by catalytic carbonylation of methanol. The catalytically active species is the anion cis-rhodium-1 complex at the top of the scheme. The first organometallic step is the oxidative addition of methyl iodide to the rhodium-1 complex to form the hexacoordinate species shown here. This anion rapidly transforms via the migration of a methyl group to an adjacent carbonyl ligand, resulting in the formation of the pentacoordinate acetyl complex as shown here. This 5-coordinate complex then reacts with the carbon monoxide to form the 6-coordinate dicarbonyl complex, which undergoes reductive elimination to release acetyl iodide, regenerating the square planar rhodium complex catalyst, and the catalytic cycle repeats. The catalytic cycle involves two non-organometallic steps. The first is the conversion of methanol to methyl iodide, followed by the hydrolysis of acetyl iodide to acetic acid and hydrogen iodide. Acetic acid is a high-demand chemical used firstly in the production of polyvinyl acetate and other polymers used in paints and adhesives. Secondly, in ester production for solvents for inks and paints. And lastly, as a chemical reagent in chemical synthesis.
TiO2 is a semiconductor facilitating photolytic reactions. When photons incide on the semiconductor, electrons are excited from the valence band into the conduction band. The excited electrons are gained by H+ ions to form hydrogen gas via a reduction reaction. The host mate then taking electrons from OH- ions, converting them into OH radicals, which can then break up to form oxygen and water via an oxidation reaction. The hydrogen gas and oxygen gas produced can then be used as fuels. Alternatively, after taking in the electrons from OH- ions and converting them into radicals, the radicals can also react with trichloromethane and convert them into harmless carbon dioxide, hydrogen protons, and chloride ions. The Ziegler-Natta catalyst, either TiCl3 or TiCl4, is used along with an aluminium-based catalyst in vinyl polymerization to make polymers of specific tacticity, such as unbranched polyethylene and isotactic polypropylene. Tacticity is a vital factor that influences the polymer's physical properties, such as rigidity, strength, melting point, and solubility in different solvents. Without this catalyst, we will need to utilize free radical vinyl polymerization, in which case we can only get branched polyethylene as some monomers will not be able to polymerize at all. In this video, we will be looking at how TiCl3 catalyzes polymerization. This is a crystal of alpha TiCl3. We can see that while most titanium atoms have 6 ligands, like the ones seen in red, some titanium atoms, such as the ones in blue, have only 5. This means that the atom has only one empty orbital for reactants to bind to. The aluminum-based catalysts have 2 ethyl groups and 1 chlorine atom, which act as ligands of the aluminum atom. As one ethyl group binds to the titanium atom, the chlorine ligand is removed. This allows the titanium to continue having one empty orbital for another ligand to bind to. An approaching propene binds to the titanium atom via the C-C double bond. Now that the ethyl group and propene are in close proximity, resonance can occur. The resonance structure shown here allows alkyl shift to happen, freeing up another orbital of the titanium atom for the next propene to bind to. The cycle therefore repeats. We can see that the process is highly controlled and the resultant polymer is unbranched.
You try so hard, but the reaction looks too slow today. To help you out, no use giving up. I made again, use me up in every phase. Transition metals, here I am. with the same face, over the ache, oxidize away. Miss of groups, take my way, move away, move away. You pump me up with heart outside, from 5 to 6. You pump me up with heart outside. I am rolling. Come home, release this iodine, and you will fall, your paradise. Wear your gloves, acetic acid may burn your wounds. Regenerate your rodeo. In the deep block, got lots to choose. Choose away, choose away. Use group 1 to reactive. Up in flames, up in flames. A chance on me, and they console.
Outside.
Chance on me, and they console.
Outside.
I am titanium.
Outside.
I am titanium.
Outside.
Dios, extra holes, taking on the electrons, burning into press. They sense on me, and electrons fall. I am titanium.
Outside.
You pump me up with heart outside. I am rhodium. They shine on me, and electrons fall.
I'm titanium.
Outside.
With my outside.